So this part is basically a review, but we need this in order to get to where we want to go today. So this is a review from what we've done. So for example, you want to simplify these radicals. So we had the square root of 24 x to the fifth. 24 x to the fifth. Now the one of your tests were those were easy to simplify. But since then, we've talked about these kinds of radical expressions. So what did you do to simplify this radical expression, the square root of 24 x to the fifth? Remember what y'all did? I think you had to turn something like that in today. Well, what you should have done in terms of the work, if you had to show the work, was this. You wrote it as the square root of 24 times the square root of x to the fifth, right? And then you simplify the square root of 24. So if you had to go off to the side, you go off to the side and you simplify the square root of 24. What perfect square besides 1 goes into 24? 6 not a perfect square. 4. So 4 times 6, and what's the square root of 4? So that's 2 square root of 6. So that's what this is right here. Right? But then now you have to simplify the square root of x to the fifth. Now don't confuse that with what you did for your test, where you had something like the square root of x to the 10th power, let's say. The square root of x to the 10th was exactly x to what power? The fifth. Because basically what you said was remember there was a rule, the rational exponent rule, that said that if you had the nth root of x to the m, then it was x to the m divided by n. Remember that? So your n was your index. So basically you said 10, your exponent 10 divided by the index 2 is just 5. Because this is really x to the 10 divided by 2, which is this. So the one of your tests was fairly easy, was that kind of problem. But now we're in the situation where 5 is not divisible by 2. So then,
Just write it as a fraction.
you could, but and we did do that at one point, but then we just did it this way. So we said that was going to be the square root of what's the largest whole number less than 5 that's divisible by 2? 4. So we wrote it as x to the fourth times x, right? And then what's the square root of x to the fourth now? X squared. So I get 2 square root of 6 times x squared square root of x. Y'all agree with that part? All right. Is that how you would write the answer? No, because we know this. We know that the square root of 6 times the square root of x is the square root of what? 6x. So that's going to become 2x squared square root of 6x. And remember, always put the radical at the end. You see that x squared, that factor x squared? So if you wrote it as a square root of 6x times x squared like that, then that looks perfectly fine. There's nothing wrong with that. But again, put the radical at the end. Because here's the problem. Some of you, and I bet I can go through those worksheets and see where a few of you may have done that. Some of you put the x squared so close to the square root, to the radical, that you're making it look like it's underneath the square root. And I can't differentiate that. So you're not going to get full credit. So in your mind, you knew that it was on the that it had to be on the outside, but you wrote it too close to the radical to where it looks like it's underneath. So in order to not make that look like that, then just write it like this, where just the square root of 6x on the outside, at the end of that expression. Okay? All right. Number 2. So what if you had the square root of 25 x to the 8th y to the 3rd? What you'll do there? kind of the same thing, right? You if you had to, you wrote it as three separate square roots, the product of three separate square roots. So in other words, the square root of 25 times the square root of x to the 8th times the square root of y to the 3rd. That's what you did. But the square root of 25, 25 is a perfect square. So what's the square root of 25? 5. And 8's an even number. So what's the square root of x to the 8th? X to the 4th, because 8 divided by 2 is 4. But here we have to do some work with this one. So the square root of y to the 3rd, I'm going to go off to the side and do it here. That's y to the 3rd. So y'all agree that's going to be the square root of y to what power? The 2nd times y. And what's the square root of y to the 2nd?
Why?
So I get y square root of y. So that's what y to the square root of y to the 3rd is. Y square root of y. So that's this right here. And notice there's only one factor that's a square root. It's already the end. So I just say the answer is 5 x to the 4th y times the square root of y. Okay? All right, number 3. Number 3, suppose you had the square root of 18 x to the 9th y to the 5th. Square root of 18 x to the 9th y to the 5th. All right, again, rewrite them if you have to, and it's a good idea to do that since those are not as simple as the one in your test. So say the square root of 18 times the square root of x to the 9th times the square root of y to the 5th. And then just go off to the side and do some work. The square root of 18, what perfect square besides 1 goes in 18? 2 is not a perfect square. 3 is not a perfect square.
9 and 2.
9. So that's square root of 9 times 2, right? And what's the square root of 9?
3.
3. So it's 3 square root of 2. So that's right here. 3 square root of 2. So all I've done at this point was simplify the square root of 18. So sometimes it's a little bit of work, but it's not difficult work. Now let's go about x to the 9th. So 9 is not divisible by 2. So I know that I'm going to end up with a square root as part of my simplified expression. So I need to rewrite the square root of x to the 9th, though, as the square root of x. Now what's going to be the exponent I'm going to use? Huh?
X to the 4th, x to the 5th.
No, I don't want to use that. You can use that, but then you have to go a little bit further. Always do this. Always use the largest whole number that's less than 9 that's divisible by 2.
8.
8. So x to the 8th times x. If you would have used x to the 4 times x to the 5th, you would have had to simplify x to the 5th even further. All right, so you're doing a little bit more work. And what's the square root of x to the 8th? X to the 4th times the square root of x. So that's this right here. So that's x to the 4th. That's this, x to the 4th, square root of x. And now I've got to simplify what part now?
1.
The square root of y to the 5th. So again, make it easier on yourself. What's the largest whole number less than 5 that's divisible by 2? 4. So that's the square root of y to the 4th times y. And what's the square root of y to the 4th now? Y squared. And you're left with the square root of y. So that's this right here, y squared, square root of y. Right, so it's a little bit of work, but easy points to get. But that's not the answer you want, though, because you know this. You know that the square root of 2 times the square root of x times the square root of y is just the square root of what?
2xy.
2xy. So you know that's going to be at the end of that expression. What's going to be in the front? 3x to the 4th, y squared. Good. So 3x to the 4th, y squared times the square root of 2xy. See, it's not that difficult. You just knowing some things will get you through the process. All right, number 4. You have the square root of 72, x to the 5th, y to the 4th, z. The square root of 72, x to the 5th, y to the 4th, z. Now before we go into that one, let's see if you can tell me this. Can I simplify the square root of x to the 4th? Yes. Why? Why can I simplify the square root of x to the 4th? Because 4 is divisible by 2, okay. So it'll be x to the 2nd, all right. Can I simplify the cube root of x to the 6th power? Yeah, that'll be x what? X to the 2nd. Can I simplify the cube root of x squared?
No.
No. Why not?
Because the power is less than the.
Okay, good. Because the exponent right here is less than the index. See, at every one we've done, the exponent was always bigger than the index. 9 is bigger than 2. 5 is bigger than 2. Right? Now we got to a point where the exponent 2 is less than the index. So we cannot simplify that. So if the index is less than the exponent, you can't simplify. Okay? All right, so we're going to need this in this situation. So I get the square root of 72 times the square root of x to the 5th times the square root of y to the 4th times the square root of z. That's what I had. So all I did was I just wrote these as a product of 4 square roots. Can I simplify the square root of 72? Yeah. What perfect square goes into 72? 36. What's your question?
Yeah.
I'm sorry. Excuse me. I meant bigger than. Thank you. So the index is bigger than the exponent. Yeah, sorry. So 3 is bigger than 2. You could have said if the exponent is less than the index. Okay, you could have done that way. All right, so that should be greater than. Normally, the way I write is I'll say if the exponent is less than the index, it can be simplified. Okay, so what perfect square goes into 72? Give me the largest. 36. So that's 36 times 2. What's the square root of 36? So 6 over 2, so that's this right here. Okay? Now let's talk about the square root of x to the 5th. I'm going to go off to the side. I'm going to figure it out. What's the largest whole number less than 5 that's divisible by 2? Okay, so I'm going to write this as x to the 4th times x. And now I can simplify the square root of x to the 4th. What is that? So I get x squared, square root of x. So that's this one right here. So the square root of x to the 5th is x squared, square root of x. Square root of y to the 4th, that's easy. What is it?
Y squared.
Y squared. Can I simplify the square root of z? No, because the exponent, which is what number? 1, is less than the index, which is 2. Or the index is greater than the exponent. But it's just square root of z, right? Okay, so what's your final answer? Good. Times the square root of what? 2xz. All right, good. Okay. A little bit of work involved, but it's not unbearable. Okay, let's do one more, and then we're going to look at where we want to go. Okay, so listen carefully to this. You have r cubed times the square root of 16 x to the 5th r to the 7th. R cubed times the square root of 16 x to the 5th r to the 7th. Okay, so we can do just like we've been doing. Rewrite it as separate square roots. So do y'all agree that's going to be r cubed times the square root of 16 times the square root of x to the 5th times the square root of r to the 7th? Okay. So I get r cubed. Now I know the square root of 16 is exactly 4. All right, now let's simplify the square root of x to the 5th. X to the 5th. So that'll be the x to the 4th times x, right? So it's the square root of x to the 4th. To get x squared times the square root of x. Okay, so that's that part. Now let's go about the square root of r to the 7th. So r to the 7th, I'm going to rewrite r to the 7th as r to what power? The 6 times r. And what is r to the 6th? R to the 3rd times the square root of r. Okay, so that's where I'm at. So what do you think is the answer, though? All right, good. So the r to the 6 is what I wanted to hear in there. So r cubed times r cubed, right? So remember, you learned a property that says that when you multiply like bases, you do it to those exponents. You add them. So the product rule. So you multiply like bases, you add exponents. That's r to the 6. And let's go ahead and put them in alphabetical order. So you're going to put the 4 first, though, and you're going to say what? Yeah, let's... ABC, I'm trying to do my ABCs. R to the 6 is first. R to the 6, x squared, times the square root of rx or xr. It really doesn't matter. Okay? All right. Any questions? Okay. Now, so that was a quick review. Well, really wasn't quick. It was 17, 18 minutes. But that was a review of some of the things that we talked about last week. Now, you're going to make sure you can do some of these on your test 4. Okay? All right, now here's what we need this for, though, with what we're about to do.